สวัสดีทุกท่านนะครับกับเรียนท่านอธิการบดีนะครับบัณฑิตและท่านอธิการบดีวิเลอร์นะครับ so วันนี้ตื่นเต้นมากนะครับนะแล้วก็ดีใจที่ทุกท่านได้มีโอกาสมาร่วมPresident Talk นะครับ Series ในวันนี้นะครับครั้งนี้เป็นครั้งที่2เราเป็นเกียรติอย่างยิ่งสำหรับวันนี้มากๆนะครับที่ have our distinguished guest speaker Dr. Andrew Eng from deeplearning.ai and Coursera นะครับที่มาบรรยายกับเราในวันนี้นะครับก็เพื่อไม่ให้เป็นการเสียเวลานะครับนะผมอยากที่จะเชิญนะครับเรามีคิวมากมายจริงๆเราอยากที่ผมขอเชิญนะครับท่านอธิการบดีนะครับศาสตราจารย์ดร.วิเลอร์ภูริวัฒน์นะครับขึ้นมาเปิดงานสำหรับงานวันนี้ขอเสียงตบมือให้ท่านด้วยครับ
สวัสดีทุกท่านนะครับสวัสดีทุกท่าน Dr. Andrew Eng AI Visionary Founder of Deep Learning AI and Coursera General Partner of AI Fund as esteemed executive from Chulalongkorn University distinguished guests ladies and gentlemen welcome to the second installment of the Chulalongkorn University President Distinguished Speaker Series. It is my great pleasure to open this event which continue our commitment to fostering international collaboration and academic excellence. Today, we are honored to explore the topic of revolutionizing the future, opportunities and business preparedness. This topic is both timely and important as we navigate the rapidly changing landscape of AI and its impact on business and society. We are privileged to welcome our distinguished speaker, Dr. Andrew Eng. A true visionary in the field of AI, Dr. Eng's contribution to the world of technology and education are truly remarkable. As the founder of Deep Learning AI, General Partner of AI Fund, Chairman of and Co-founder of Coursera, and an adjunct professor at Stanford University, Dr. Eng has been at the forefront of AI innovation and education for years. Dr. Eng's insight into the technology landscape, AI opportunities, and how businesses can identify and leverage these opportunities are invaluable. His expertise will undoubtedly provide us with a deeper understanding of the risks and social impact of AI, as well as the upcoming technology trends that will shape our future. Moderating today's discussion is Assistant Professor Dr. Kavin Aswanon, Director of the Technology Management and Entrepreneurship Program here at Chulalongkorn University. He is also the alumni of Stanford University. Dr. Aswanon's expertise in technology management and entrepreneurship will ensure a thought-provoking and insightful conversation. This event builds upon the success of our first session, where we explore leadership in a disruptive world today. We delve deeper in the specific technological disruption that are reshaping our world with a focus on AI. I encourage all participants to engage actively with the idea presented. Before we begin our session with Dr. Eng, I would like to extend my gratitude to all those who have made this event possible. Special thanks go to our organizing committee, faculty members, and staff for their efforts. I would like to also thank and acknowledge the Technology Management and Entrepreneurship Program, Graduate School, Chulalongkorn University, for their effort and putting together in this event. I look forward to an inspiring and thought-provoking discussion that will contribute to our understanding of AI's role in shaping our future and preparing our businesses for the opportunities that lie ahead. Thank you very much all for your presence and participation. Thank you very much.
Thank you very much, Professor Willard, President of Chulalongkorn University. So before we get started, I just would like to explain about the format on today's special session. So the first beginning, we will have lecture on the technology landscape and what's the AI opportunities here, that from the visions of Dr. Andrew, who touch on many of the areas in the world, not just United States. So once we finish with the lectures, we will open up for Q&A, probably about 30 minutes, right? So I encourage you to prepare some discussion, some ideas that you would like to ask. I'm sure that many of you here today have taken the class AI for Everyone, Gen AI for Everyone, right? It's the first time that I feel being in academic is similar to being Lisa in Blackpink, right? So he's like so popular among the academics and the forefront of AI in Thailand here. So yeah, so we will have a lectures and we will have a Q&A. And after we finish with the Q&A, I ask you, like for any individual question, we will line up and have some time to, similar to meet and greet with the K-pop star for sure, right? But we will ask you to line up and then have a chance to ask and maybe take some photos with Dr. Andrew so that not to be overwhelmed with the guest speakers today. Okay, so without further ado, right, I would like to warmly welcome Dr. Andrew Eng, our guest speaker today.
Thank you. It's really good to be here. You know, when I had the opportunity to visit Thailand, I really wanted to visit Chula because every time there's a new, innovative, disruptive technology, the leading university always plays a critical role, helping everyone in the country understand the technology, bring in knowledge from the global research community, and make connections to how we could use it here in Thailand. And over the last week, as I visited many different businesses, had the opportunity to meet with some government leaders, I was really excited. I was really excited to see the amount of momentum and activity here in Thailand in AI, where people don't just talk about AI, but many people, I'm embarrassed to admit, more than I had realized there was, are actually building AI. So seeing that momentum in Thailand, as well as Chula's unique role in supporting all that, was very exciting to me. So what I hope to do is chat with you about what I see as some opportunities in AI, and I hope that I'll be back in Thailand again in the future, but I hope that this meeting will be just the beginning of a long-term relationship to try to find more things to do together to support the growth of AI in Thailand. So AI, I've been saying AI is the new electricity because one of the tricky things to understand about AI is a general purpose technology, meaning it's not useful just for one or two applications, it's useful for a lot of different applications. Kind of like electricity. If I ask you what is electricity good for, it's almost difficult to answer that because it's useful for so many different things, and AI is like that too. I thought I'd briefly touch over the technology landscape and then talk a bit about the opportunities, including opportunities for universities to do much more for ourselves, for our students, for all of society. With all the buzz about AI, I think a good way to think about AI is actually as a collection of tools, where the two most important tools are a technology called supervised learning or predictive AI, sometimes using deep learning, and then the new entrant is generative AI. And if you study AI, you may read about other tools, but what I want to do today is focus on the two most important tools in AI today, which are supervised learning and generative AI. So supervised learning started to work really well maybe 10, 15 years ago, and is very good at computing input to output or A to B mappings. So for example, if you input an email and label it as spam or not, that's supervised learning. The most lucrative application of this I've ever worked on, not the most inspiring, but highly effective one, was for the large ad tech platforms, which all have an AI that inputs some information about an ad and some information about you, and tries to label that with whether or not you will click on that ad or not, because showing slightly more relevant ads has a direct impact on the revenue of the ad tech platforms. For self-driving cars, we input a picture of what's in front of your car, label it with where are the other cars. We use it for ship route optimization. Given a ship route, label it with how much fuel consumed. We do a lot of work in manufacturing where we take a picture of a smartphone and label it with whether or not there's a defect. And then something that I'll use as a running example is reputation monitoring, where you might input a restaurant review and label that as, does this have a positive or a negative sentiment? To use the reputation monitoring as an example, this is what the workflow of building an AI system using supervised learning looks like. You start by collecting a data set, meaning a big table of lots of examples like this, where you may say the Gui Diu Tom Yum was great, that's positive. Served was slow, that's negative. My favorite Pad Thai Gu Yum, that's positive. And given a data set of hundreds or maybe thousands of reviews and labels, you would then take that label data and train an AI model on the data, and then maybe find a cloud service to run the trained model, so you can feed it best great thought I've ever had, and it'll label that as positive. And it turns out that the last decade was maybe the decade of large-scale supervised learning, because we found that if we trained a small AI model, so on a small computer, not very powerful, not a very powerful GPU, we found that even as we fed it more and more data, its performance would flatten out, or plateau, it wouldn't keep on getting better. But we found that if we train a very large AI model, large computer, one or even multiple GPUs, then the more data we fed it, the better the performance got. This is why when I started the Google Brain team, the number one direction I gave the team was, I said, let's just focus on building really, really large AI models. And fortunately, that recipe worked, and this recipe has actually driven a lot of AI progress over the last decade. But if the last decade was a decade of large-scale supervised learning, I think this decade is turning out to be the decade of generative AI, where I know many of you will have used tools like ChatGPT or Claude or Gemini, where you can input a prompt and have it generate different completions. I love eating yen tafo, mom's kway jiao, roti glai. And given the amount of buzz about this, I want to take just half a slide to try to demystify how generative AI works. And it turns out, at the heart of generative AI is using supervised learning, input A, output B, to repeatedly predict the next word. So if an AI team has scraped the internet and found a sentence, my favorite food is mango sticky rice, then this one sentence is turned into many data points to try to predict what's the next word. So for example, given the fragment, the sentence fragment, my favorite food is, the next word is mango. Favorite food is mango, what's the next word? Sticky, and so on. And it turns out that when you train a very large AI system on a lot of data, over 1 trillion words, sometimes more than 10 trillion words, then you get a large language model like ChatGPT. I'm simplifying important details away. Technically, we don't predict the next word. We predict the next word fragment or part of a word. And there's some of the things we do to try to make sure these systems are more hopeful, follow instructions, more safe. But leaving aside those details, the heart of generative AI is repeatedly predicting what is the next word. And in addition to generating text, generative AI is also generating images and audio. A couple image generation examples. And in terms of audio, I'm going to show you a fun audio clip. It turns out commercial off-the-shelf voice clones are actually getting really good. This is a clone of my voice.
Dear friends, AI is progressing faster than ever. This is thrilling yet rapid, those without. Even as the AI world brings breakthroughs seemingly every week, you'll be better off with friends to help sort out what's real. Dear friends, AI, dear friends.
Yeah. not sure you could hear that, but I think off-the-shelf voice clones are actually getting pretty good. Maybe one fun thing, I showed a voice clone. I let both of my parents listen to a voice clone of me, and it successfully fooled one of my two parents. And I will never say which one it fooled and which one it didn't, because that would get me into trouble. Now, with these exciting technologies, it's also opening up a lot of new use cases. In fact, one thing you might be using large language models for already is things like answering questions, using as a brainstorming partner, copy editor to fix our writing summaries. And I think with these general purpose use cases, I think every knowledge worker can get a meaningful productivity boost today by using generative AI. Now, in addition to going to the web user interface, like the OpenAI or the Anthropic or the Google website to use generative AI like this, there's another class of ways of using generative AI that I think is important, which is building software applications using generative AI, where instead of one of us going to a web browser to use it, there are a lot of developers writing software to call generative AI, and that is making certain applications much easier to build. So specifically, if we were to look at the restaurant review example, if we were using supervised learning to build that restaurant reputation monitoring application, the workflow might involve getting hundreds of thousands of data points, and that might take a month. And then finding an AI team to train a model and tune it might take 3 months, and then deploying it and making it rugged, maybe another 3 months. And this workflow worked, and a lot of teams spent 6 to 12 months to build these AI applications. It turned out to be very valuable. But it turns out for certain types of AI applications, with prompt-based AI, it takes maybe minutes or hours to specify a prompt, and then hours or days to deploy that online. And what this means is there are now many AI applications that have taken me or taken good AI teams 6 to 12 months to build, that today there are hundreds of thousands, maybe of millions of developers that could do the same thing in a week or less. And this dramatic reduction in the work needed to build certain applications from 6 months to maybe less than a week is leading to flourishing of the types of AI applications that many people are building. So let me just show a concrete example. Let's see. So it turns out if I want to build a reputation monitoring system, this is all the code I need. Import some tools from OpenAI, write a helper function, and then, write a prompt, classify the following as positive, negative sentiment, loved. Things like Chula, lots of exciting AI projects and good conversations. Never run this before, so, right. All right, thank goodness it got that right. But this is literally all the code that you need to build a sentiment classifier. And this is making building these AI applications much easier than was ever possible before. Sorry, let me find my... And in terms of applications that people are building, these are some of the maybe most commonly built corporate AI applications. The one I hear about the most is corporate Q&A, where we build AI to answer questions using a company's documents, either to serve internal employees or to serve external customers. Because generative AI tools have made it much easier to build chatbots, there are a lot of customer service chatbots being built by many companies. I see many companies using generative AI for summarization. We all have too much text to read, so you can summarize. That can speed up internal communications. Routing emails and messages to the right person. There are a lot of specialized chatbots to advise people on healthcare, travel, cooking, on legal matters, on romantic relationships. And then there's one weird application, which is the fake girlfriend, fake boyfriend industry, which I think actually has some ethical challenges as well. So there's some weird parts, dark corners of what people are doing with generative AI. And then also entertainment. But these are some of the examples of applications I hear about a lot. And with all of these applications being possible, I find that there are a lot of new opportunities for all of us to build new things. So there was a puzzle that I want to solve a few years ago, which is I saw that many valuable AI projects are now possible that were not possible before. And I want to figure out how to get them done. And I felt that even though I had led AI teams in big companies like Google and Baidu, I couldn't imagine how I could operate a team even in a very good big tech company to pursue the large range of AI applications that are now possible. So I decided that starting many new companies I felt would be an efficient way to pursue many of these projects. But it turns out the incumbent companies, I've been meeting with many large businesses here in Thailand the last week. Many incumbent companies also have opportunities to build and integrate AI into existing businesses as well. But to be concrete about where are the opportunities, this is what I think of as the AI stack. At the lowest level is the hardware layer, so the semiconductor, and then cloud layer, and then the AI tooling layer. And it turns out that all of these layers tend to be, can be quite capital intensive, so need a lot of resources to build semiconductors or build a cloud, and also somewhat concentrated. So it's not that easy for new entrants to play at these layers. And for AI tools, I tend to build teams there only if we have a unique technology. But it turns out that even though a lot of the media attention, a lot of the press and social media tends to talk about these layers, and that's fine, the media likes to talk about the technology layers, it turns out that for these teams to succeed, there's one other layer that almost by definition needs to be even more successful, which is the application layer. Because for the tool builders, or the clouds, or the semiconductor makers to be successful, we actually need the application layer to generate even more revenue so they can afford to pay the infrastructure layers down below. And as I wandered around Thailand and spoke with many groups in business, in academia, startups, I think that there are so many exciting opportunities to build many different applications to the many businesses or for-profit, non-profit applications that are uniquely Thai. And one of the things I wound up doing at my Team AI Fund was figure out a process for building startups. So I want to just share that with you. I know that many people from your business school have a strong entrepreneurship interest. But I want to illustrate this with an example of something that we did. So my team has always chatted with many partners, and so try to identify a lot of different ideas for projects, ideas for startups. And so a few years ago, a large Japanese conglomerate called Mitsui Corporation came to us, and they said, hey Andrew, you should build a startup to use AI to make ships more fuel efficient. And this became Bearing AI. But what we did in our typical process now, we look at the project and we try to assess if there is a market need there. Do people need to use this? And is this project also technically feasible? And if it is, then we go out to recruit a CEO to work with us to build it. And in this case, recruited Dylan Kyle, who is a repeat entrepreneur that successfully built and exited one other startup before. And we then spent 3 months with the CEO building a prototype. And if after this it still looks promising, we then fund the startup, which gives it resources to hire key executives, build an MVP, get early customer traction, and then company can continue to raise funding and keep on growing and scaling. So because of this company, Bearing AI, now uses global weather patterns and global ocean current data and other types of data to suggest to ship how to steer to get it safely and on time to its destination while using about 10% less fuel. It turns out if you're a ship captain, should you sail your ship at 20 knots or 22 knots? You know, who knows? And a ship captain would just make some decision, often based on gut or experience. But with data, we can often make a specific recommendation on direction and speed that actually gets you there on time with significantly less fuel. So today, Bering AI is steering 600-700 ships on the high seas right now and saving about $500,000 US per ship per year, and maybe even more importantly, reducing CO2 emissions by about 10%. And I find that as an AI person, you know, what do I know about global maritime shipping? So I find that as an AI person, I often do my best work if I can find a subject matter expert that deeply understands where to apply it, so they work together to use my team's AI expertise, and in this case, Mitsui's expertise in global shipping, to work together to build a project that, you know, I would never have thought of doing this by myself. And one of the exciting things about this week in Thailand was the number of domains in Thailand that hopefully my team can provide AI assistance to work on solving. Now, I think that AI has many opportunities, and I also want to just touch on some of the risks and social impact. So I know that people often wonder if generative AI will lead to job loss. And this is a chart from a friend at University of Pennsylvania and some folks are working at OpenAI that analyzes the exposure of AI, the exposure of different jobs to AI automation. So the x-axis is salary in US dollars, and the y-axis is the exposure of the jobs to AI augmentational automation. And the interesting thing about this chart is the jobs to the right, the higher salary jobs, are actually more exposed to generative AI automation. And this is unlike earlier ways of automation. Think of, say, factory automation, where it was the lower wage, more routine, repetitive work that was more susceptible to automation. And this is also why I think all knowledge workers today can use generative AI to become more productive. Although one caveat is workers do need a little bit of training to use it more effectively. And earlier I was learning about some of the really nice work that of Chaloem, that is providing education on campus and even more broadly to Thailand. So I think that's very meaningful to help more people learn to use it effectively. And then in addition to personal use of generative AI on the web, it also creates a lot of opportunities to build new software applications, you know, that weren't possible before. And this is another data set. We took data from McKinsey and reanalyzed it, so you won't have seen this chart before, since this is our analysis of McKinsey data. But this shows the incremental impact of generative AI on automation in different sectors. And it turns out that some of the sectors most affected by generative AI are things like educator and workforce training, business legal professions, STEM professionals, and so on. And I think for the university too, over the last several days, I actually read in detail the Chula AI plan, and I thought it was actually very thoughtful. And I think for universities too, you know, as in your Chula AI plan, the impact of generative AI on teaching and learning, as well as on university operations, I think will be significant, and so is beholden to those of us from the academic system to figure out how we could use AI to do better teaching and learning, as well as to improve the efficiency or improve the service of university operations. Now, if you are wondering, you know, there are these ideas, but where do I find ideas for concrete projects to work on? I want to share with you one recipe that I've used multiple times to identify AI project opportunities that I found to be very fruitful. And this is a framework called the task-based analysis of jobs. And this was pioneered by my colleague Eric Brynjolfsson at Stanford and some of his collaborators. But it turns out that many people worry about AI automating jobs, And that is an important discussion to have. But from a execution or a business or a computer science product perspective, I find it more useful to think about AI as automating tasks rather than jobs. Because jobs are made out of many different tasks, and AI automates individual tasks rather than automating jobs. So what I've actually worked with many teams to do is look at the tasks that people are doing, and then at the task by task level, analyze them for AI potential. And this often leads to ideas for projects we could then build. For example, customer service representatives is one of the job categories most impacted by AI. And it turns out customer service representatives actually do many different tasks. And some of the tasks, like answering customer text chat queries or keeping records of interactions, have high AI automation potential, whereas others have lower AI automation potential. And so this analysis almost always, very often, gives ideas for projects to do. And it turns out when we do this analysis, we find that for many jobs, maybe 20–30% of a job can be automated. And the good news of that is if 20–30% of the job is automated, then 70–80% of the job still needs to be done by human, and so the job's not going to go away. We still need people to do that work. So I'm not saying that AI won't lead to any job loss. There is a small fraction of jobs where AI can automate close to 100% of it. And for those jobs, I think we have a responsibility to make sure people are taken care of and that the wealth we create is fairly shared. So for example, creating a safety net to make sure people whose jobs are affected have an opportunity to keep learning and reskill to re-enter the workforce, I think is important. But for the vast majority of jobs, if 20–30% is automated, then what that means is the job is going to be there. And it also means AI won't replace people, but maybe people that use AI will replace people that don't. And I think that creates a strong obligation and challenge for us to provide upskilling to make sure everyone learns to use these tools and keep up with these increasing ways of automation. And I want to share one more optimistic note with you, which is when I present this recipe, I know this looks like a recipe for cost savings, right? Figure out what people do, automate some of it. And it turns out that when you do this with a company, sometimes if you make one task 1,000 times cheaper, sometimes the company will want to take the cost savings, and that's fine. But much more often than you would guess, the company will say, oh, if I can make this task 1,000 times cheaper, then I want to do this task 10,000 times more, because then I can serve customers better and drive growth. And what I've seen is saving money is nice, but there's only so much money you can save. But the upside to growth has no limit, no ceiling on that. And so even though this looks like a recipe for cost savings, when you start this way, quite often you find that companies end up wanting to pursue growth rather than just cost savings, which also means that jobs might be less impacted than people are initially worried about. So talk a lot about opportunities in AI and some ideas for pursuing them. I want to wrap up with just sharing one AI technology trend that I'm excited about, and that those of you building applications I hope you will consider, which is AI agentic workflows. And I see this having a huge impact on lots of applications today. So it turns out that the way most of us use a large language model or generative AI today is with something called zero-shot prompting. But what that means is we ask it to write an essay for us on a topic. And that's a bit like going to someone, maybe a human, maybe an AI, and saying, I want you to type out an essay for me on this topic by typing from the first word to the last word all in one go and without ever using backspace. And as a person, I can't write that well like that. And for AI too, it could do it surprisingly well, but this is not the easiest way to write. Or when you use AI to write code, this is like going to a computer programmer and saying, I want you to type out the computer program. Just type out the program for the first and last character, and then I'm going to run whatever you typed out, and you can't ever go back and edit it. And, I can't write code like that. In contrast, with an agentic workflow, we let the AI think about this work and revise it. With an agentic workflow, we ask the AI to first write an essay outline on a certain topic, and then we ask it, do you need to do any web research? If so, search the web. Then write a first draft. Then we ask it, read your first draft and think about what parts need revision, and then revise the draft. And it goes on like that. So this looks more like having the large language model do some thinking, and then revise, and then go back to do some more thinking. And this much more iterative workflow for many applications is causing generative AI to write much better outputs than the option on the left, zero-shot prompting. And so my team collected some data of many different pieces of work that different people had done on a coding benchmark. The coding benchmark released by OpenAI is called Human Eval. But it turns out that GPT 3.5, zero-shot, this is, we asked it to just type out the code, right? It gets it 48% right on this benchmark, on the Parsec K metric. GPT-4 is much better. Performance goes from 48% to 67%. But the improvement from GPT 3.5 to GPT-4 is still much smaller than if you use GPT 3.5 and wrap that in an agentic workflow to let it think about its own work. And similarly, GPT-4 with an agentic workflow also does much better. This is just coding benchmarks. In the work of my teams and a lot of my friends' teams, we see over and over that using an agentic workflow delivers much higher quality results. And I think earlier, I really enjoyed learning about the DMind project, and I think that also uses an agentic workflow to get much better conversations with people with, suffering from depression. Just to give you a concrete example of one simple agentic workflow, I didn't want to leave it too mysterious. This is how the simple agentic workflow might work, which is I might go to a large language model, and I'm going to call it a coder agent, but I'm just going to prompt it, please write code to do a task. And maybe the LLM will write some code. What we then do is construct a prompt that looks like this, to say, here's code intended for a task, and then we paste back into the prompt the code that we just got back from the LLM the first time around. So take the output, feed it back to the input, and we ask it, read the code carefully, check for correctness, style efficiency, give constructive criticism. And it turns out the LLM can then say, oh, there's a bug in line 5, maybe we can fix it. Then we can give its own critique back to the LLM and say, write the code again, and it will improve the code. And then if we actually tell it, if we actually allow it to do some testing, run some tests on the code, then maybe we'll find, oh, it failed unit test 3. And then take the result of a unit test, feed that back to the LLM, and have it rewrite the code so it can improve the code again. And so this is an example of a simple agentic workflow called reflection, where if the LLM generate output, have it reflect on its own output, and use its own reflection or its own criticism to try to improve it. And this actually makes it work much better. And maybe one design pattern as well is we find it often useful to think of building multi-agent LLM systems, where instead of thinking of building one AI agent, you can think of there being a coder agent and a critic agent, where we prompt the critic agent to critique the coder agent to give feedback that is then used to improve the coder agent's work, and this derives significantly better results. So there are multiple design patterns for agentic workflows, and this is just one of them, but I find that this is exciting because this technology is significantly expanding the set of tasks that we can now do with generative AI, and this is letting us solve more and more problems, and this technology is continuing to get better rapidly as well. So I think as exciting AI is, the technology continues to get better, and I hope that all of you will keep on using these tools and keep building exciting applications for yourselves and for others around you. And then I've just one last slide, I'll wrap. We'd love to take questions after that, which is, in these last few days I've spent in Thailand, I became really excited and really optimistic about the future of AI in Thailand, maybe for a few reasons. I think AI by itself is totally useless. It's only when you find meaningful applications to apply to, then it becomes useful. And I think Thailand's key strength in important application sectors, including tourism, healthcare, agriculture. Over the last week, I actually spoke with many teams on brainstorming different ideas to use AI to these key sectors. And I think that in the next few years, there'll be a lot of opportunities to do projects on topics that Thailand is uniquely good at. And just as an example, there are projects that you could do in Thailand on tourism that you will have a much better shot at working on it than I could do in Silicon Valley, because the tourism is here in Thailand. So I think that opportunity set of opportunities for applications here is very large and very interesting. And then as I had the privilege of meeting many people working in education, including the Minister of Education, Minister for Higher Education, and quite a few others, I feel like you know better than I do, this is a country with a very strong commitment to education, and especially in moments where this disruptive technology, education and training becomes more important than before, because we need resources, we need ways to train up existing workers on new technology as well as future students on new technologies. So I'm actually excited about the explorations to try to teach every school child, even primary and secondary education, some computing or some computer science, so that hopefully someday as they grow up, maybe everyone will know how to code. I think that would be a very powerful force. And then something I really enjoy getting to know is the tremendous momentum here in Thailand in the AI, including the academic, but more broadly the AI as well as the startup ecosystem. And I know that right now Thailand is not as advanced as the US or China in AI, but having worked in a lot of startups and small businesses, there's one thing that I think is even more important than how big and successful something is now, and that is how much momentum it has. And in fact, when I look at small startups, they can be small, but if they have momentum, that matters more than the size you have right now. And you might see this even more clearly than I do, but as I was meeting many teams around the country, government, private sector, and then today I had the privilege of spending quite a few hours with your faculty talking about projects like Deep GI and DeepMind and many other projects. I feel like broadly, Thailand has tremendous momentum, and that's actually more important as we project into the future to where we could get. So having spent most of this week in Thailand, I really believe in the future of AI in Thailand, and I hope you will believe in the future too. And looking in the future, I am working already with some partners in Thailand. We announced a partnership with K-Bank, but hopefully others as well in the future. I think that there'll be lots of opportunities for all of us to keep working together in academia, in industry, also partners in government to keep on lifting up Thailand's AI. And I look forward to hopefully being allowed to continue to play a small role supporting this great work that I think so many people in Thailand are doing. So that, look forward to the conversation, but let me just say thank you all very much.
Thank you so much, Dr. Andrew. So I have such inspiration from you about Thailand having momentum and commitment for the education. So now we are probably in the session of everyone looking forward to So we will open for Q&A from the audience and from everyone here. So anyone who have questions, please raise your hand, and we at the staff will come and give the microphone to you. ครับเชิญครับเชิญครับพี่เลยครับ
Hi. The rise of AI adoption has also led to the new society problems, especially in data privacy, cybersecurity. I would like to understand your thoughts on the machine learning technology, especially in federated learning, decentralized machine learning, as well as the fully homomorphic encryption. Is privacy-preserving technology aligned with your investment mandate, or what's your thought on it? And are we close to that ideal time that we can really see data protection has been in a good situation?
Can you introduce yourself, please?
I'm sorry. My name is Miranda. I was your student in 2017.
And what are you doing right now?
I run a fund as well as I run a software company, but we built a infrastructure technology by combining machine learning into a blockchain for a data immunities and federated learning swarm intelligence. That's my area of interest and passion, because I believe that the more AI has been increasingly hyped, sadly we see that all the unfortunate events that many people has been stealing private information or has breached it.
Kun Brenda, what's your questions again? Can you repeat your questions again?
My question is, what is his thought on the topic, on the subject that I has mentioned?
What's the start on the subject?
Yeah. What is your opinion on the privacy-preserving technology?
Yeah, so I think privacy is important, right? And I think there are different privacy-preserving technologies. I don't know if you remember when differential privacy first came out. It felt like a little bit of a PR stunt, right? But serious academic researchers were working on it, and today differential privacy is a very important mechanism that is genuinely helping people's privacy. So differential privacy is when we add a little bit of noise to data to preserve your individual identity, like preserve your GPS location, or to take your text and add some noise to it so people can't recover your ID number or credit card number. And this technology works, and it really is preserving people's privacy. You mentioned federated learning. I know, actually, I feel like this is actually one of Chula's strengths, with multiple research groups publishing very interesting work on federated learning. I think it's an important technology. I think we're just slowly getting there. I don't think federated learning has really taken off yet, but there's certainly more and more hospitals looking into it seriously. I remember when I went to, it was before the pandemic, the last NeurIPS conference before the pandemic. I was going to the healthcare workshop, and there were tons of papers on federated learning for healthcare, but almost no deployments yet. But I think we'll get there. So actually, this is not public. DeepLearning.ai has been working on some short courses on federated learning that hopefully will, release soon as well. So I hope that differential privacy, federated learning, other techniques, I hope that we can keep on finding new mechanisms to preserve privacy, I guess.
Thank you. And what about the homomorphic encryption?
Sorry?
What about the homomorphic encryption? The encryption technique that you can encrypt the data, and then you can still train AI models on top of the encrypted data without decryption.
I see. I think it's a great idea. Given the computational cost, I don't know of any scale deployments of that yet, but what we see over and over is often in academia, we have to work on a technology for years to figure out the details, and then it takes off. So I think from an academic perspective, we should absolutely keep working on it, but in terms of practical deployments, I think probably more basic research needs to be done before that takes off.
Thank you so much. Thank you.
Thank you. So next question. Does anyone have next question? I see, let's say from the back, the gentleman in the back next to the camera. ช่วยแนะนำตัวยืนขึ้นแล้วแนะนำตัวสักนิดก่อนครับ
Okay, very much for choosing me. I'm known one of the students, master student from Dr. Wheeler's class. And right now I'm working for like a business transformation projects for local Thai companies, which AI could be a good use to the transformations. One of the things is we know the risk as about on the jobs effects, but I would like to know your opinions about the risk if we rely on AI too much, such as what happened at CrowdStrike today when the system gets updated and everything goes like down. Thank you.
Yeah, no, I actually feel bad for the people at Microsoft. I think, you know, there was the Azure hack like just 1 or 2 months ago, and the problem with that is once hackers got into, you know, anyway, I hope it was resolved quickly. So let's see. It turns out that risks of relying on AI is often, the risks are often not a function of the technology, but a function of the application. So I find that, you know, if I use a AI model for medical devices, then there's certain risks of medical devices, a patient, you know, the wrong label and so on. Whereas if I use AI for an electric vehicle, then an EV has totally different risks than a medical device. Or if I use AI for underwriting, for deciding whether or not to approve a loan application, then the risks there of bias, discrimination, you know, mistakes in writing loans are very different than the risk for electrical vehicle, are very different for the risk of medical device. So when I'm building applications, there's one technique I often use, which is, and then there are also some AI applications where, for example, we do a lot of work inspecting things in factories, and if you're inspecting smartphones in a factory for whether or not there's a scratch, you know, I don't think there's meaningful risk of discrimination against certain types of people and so on, but the risk profiles are very different. But so there's one practice that my teams often do, which is we use a technique called FMEA analysis. But what that means is basically sit down and brainstorm in advance all the things we could think of that might go wrong. And then for some industry sectors, for example, in banking, there are already some standards for what are the risks of AI for, say, underwriting loans. But I found that when a team really seriously brainstorms all the things that could go wrong, it's very rare that something will go wrong that we did not already think was a possibility. Not saying it will never happen, but it's actually, you know, quite rare. And when we're brainstorming in advance all the things that we think could go wrong, then we're often in a better position to figure out how to make sure a certain thing doesn't happen, or put in place monitoring and metrics to get early warning in case something is going wrong, and also put in place mitigation plans. So for quite a lot of my AI systems, we have a plan to say, we're going to deploy this, but if something goes wrong, we're going to roll back. We're going to undo the thing we just deployed to go to an earlier version, just take it offline right away. But I find that with those tactics, which are more a function of the application, we can then often mitigate, you know, maybe not 100%, but mitigate a lot of the risks.
Thank you.
Okay, thank you. Next question to the lady in the side. ขอไมโครโฟนนิดนึงครับรบกวนแนะนำตัวก่อนด้วยนะครับ
Hi, my name is Piyaga. So I'm the new freshie of the CU tip or 18. Yeah. So you have mentioned in terms of the new trend or of the AI. You mentioned about the agentic AI, right? So do you see that this agentic AI is the ultimate AI, or it should be, there will be something else after that?
I think there'll be something else after that, and then something else after that. I think that there's so many people. I think it's wonderful how many people are working on AI right now. But what that means is, with so many brains thinking about AI, it's simultaneously advancing on many different fronts. And so I think there'll be new breakthroughs, you know, many new breakthroughs every year for a long time. So maybe, for example, agentic AI workflows is one technology I'm excited about, but other directions I find are exciting. I think AI on device is really taking off. So, you know, I think that I routinely run a large language model on this laptop, right? So if I'm on an airplane and don't have internet access, on-device AI is getting much better, and the smaller models, the largest model I run on my laptop is 70 billion parameters, but the smaller models, 7 billion parameters, runs pretty fast, and the small models are getting much better. So on-device AI is really taking off. And then I think also we saw large language models revolutionize the way we process text, but I think the image processing revolution is happening maybe 1.5 to 2 years after the text processing revolution. And by image processing, I don't mean image generation. Image generation is nice, but I'm seeing image analysis, the ability to look at a picture and see what's in the picture, also becoming much better. And this will have implications for how we inspect things in factories. It will have implications for how we process medical images, or how we process drone imagery, or for self-driving cars. I think we'll be able to see things around our cars much better. So I think these are other examples of trends. In addition to agentic AI, I think seeing breakthroughs in on-device or edge AI, breakthroughs in large vision models or large multimodal models for visual processing, and then there are many other topics that people are working on. So I think we'll see multiple breakthroughs.
Okay, Professor Andrew, maybe you can bring.
Oh,
so next question. Before the next question, I just like to give some pause and would like to say that I get the chance to spend some time with Dr. Andrew in the past few days, and just realized that this is his first time in Thailand. All the years that have passed, this is the first time, and hopefully it will be many more time before that. Right, so yeah. Okay, so let's get from Ajahn Manoj, please, from Vice President Ajahn Manoj.
Hi, we met earlier. I have a question about, you talk about the dichotomy of the AI technology and applications, and talk about the regulating of AI. So what's your thought on the regulations on ethical use of AI, and how we should go about doing the regulations? Thank you.
No, thank you for that question. Let me share a slide to actually share a deeper perspective on that, because I think this is an important topic. So responsible AI is important, and I think when thinking about regulations, I like to distinguish between the technology and the applications. So an electric motor is a technology, and when you put it into a blender or electrical vehicle or a dialysis machine or a guided bomb, it becomes an application. So technology refers to tools that can be applied in many different ways to solve problems, and applications are specific implementations that meet a particular customer need. And AI has a similar picture. A large language model is a technology, and when you put it into a medical device, social media feed, chatbot, or a political deepfake, then it becomes an application. So it turns out risks are more a function of the application rather than the technology. And I see some governments, not the Thai government right now, but other governments, unfortunately try to regulate the general purpose technology. And imagine if you go to an electric motor maker and say, I want you to guarantee that your electric motor will never be used for a harmful purpose. We don't want electric motors to be used for harmful purposes, but I have no idea how an electric motor maker can guarantee no one will ever take that motor and put it in a guided bomb. And the same thing is true for AI in terms of today's technology. I don't know of any technology that lets someone release a large language model, say it's open source, and guarantee that it's impossible for anyone to ever use that for a negative or harmful purpose. So if we were to pass such laws, the only thing the electric motor maker could do is just say, let's not make any more electric motors. And similarly, the technology does not exist to let someone, say, release an open source large language model and prevent anyone from fine-tuning or training it to do something negative. Now, of course, I think the number of positive use cases vastly outnumbers the number of negative use cases. And in terms of protecting people, it will be by examining specific applications, like that lets us figure out what do and don't we want in medical devices, or what do and don't we want in social media feeds and so on, that lets us pass laws to enable good use cases and squash negative use cases. And one thing that really took me by surprise was the intensity of the lobbying against open source. So open source is a critical part of the AI supply chain. It's also a critical part of how academia can have access to large language models to study them. And I think the ability of researchers to study the technology is a very important piece of the puzzle to understanding risks and improving safety. So last year, we saw some large companies that had invested a lot of money into training large language models. And understandably, if you spend tens of millions of dollars or more training a large language model, if someone else releases a similar model as open source, well, that really degrades the value of your investment. That's not, very good for your business. And so last year there was really took me by surprise how intense it was, lobbying efforts to convince governments to pass stifling laws under the false guise of safety to try to shut down open source. Fortunately, we've beat back a lot of the efforts to stifle open source. We're not yet done. There's still some very worrying regulations being proposed. But if these laws had passed, I think there would be a very small number of companies that would benefit, and almost everyone else would be worse off, including almost all countries, including Thailand, that would find it much harder to access open source large language models. So one interesting thing was I saw, unfortunately, how effective some of these lobbyists were at convincing the European Union to regulate against the European Union's own interests. In the United States, a lot of friends and I spent a lot of time in Washington, D.C., to try to talk to regulators. And I think the U.S. Congress is okay, although even now there is a fight on in California with open source defenders fighting against a really bad regulation proposed in California that would be very stifling of open source, SB 1047. So I think that that conversation continues, and if any of you get a chance to do so, I hope you will help protect open source, because it's really one of the most precious mechanisms for research and innovation and dissemination of this technology.
Thank you, Dr. Andrew. So that's the distinction between technologies and application, and then we should focus on the threat, on the danger of the application level rather than on the technology level. Okay, come with the next questions. Okay.
Hi. Very nice. Dr. Rangsen, thank you for mentioning our DGI. I'm part of the DGI developer, also in charge of innovation. My question is quite similar to your answer, but it's in a different aspect. Regard to the responsible person, let's say my DGI is detecting colon cancer and polyp, but is something wrong with my system? Who will be the responsible person? The user, the purchaser, the hospital, or the developer, me, or someone else? On the other hand, I feel very confident about my reading without needing AI. Somehow I made a mistake in the future. Said that, and the patient found that I did not use that very well developed AI. Is it my fault?
Yeah, I think this is one of the places that regulators can really help. The liability for medical AI is still a little bit confusing. In the US, usually if you get through FDA approval, maybe that gives some protection. And then in the United States, less sure about Thailand, often there are the terms of service that are often written by the developer that allows the developer to get users to agree to certain liability arrangements that therefore often favors the developer. But then sometimes there are lawsuits to argue that the terms of service were not fair. So not a lawyer, not giving legal advice, but I think this is one of the places that regulators could make a real contribution. If regulators step in and say, we want more AI for healthcare, but these are the rules, and if you do this, there's a safe harbor. You won't be liable. If you do that, then you are liable, and different people are liable at different positions. So I think that bringing that type of regulatory clarity would be one good place that government can create clear rules to then enable innovators to decide what products they want to ship. So.
Thank you, and let me share this to the bigger audience. So now from Ajahn and the Jula research team, we have a chance to share the latest technologies called Deep GI, which help doctor, surgeon to detect colon cancer. Right? So that technology is able to go through to your colon and help nurses and surgeons to detect whether you have potential polyp, potential cancer cell in the colon or not. Right? According to Ajahn, asking like, what if my AI is not detecting and the patient is, sent home and later on this become the cancer that undetected? Is the liabilities relied on who, right? So from Dr. Andrew, he said this is where the regulation, the government can come into play. So help save the people who pioneering on AI, because nothing is 100%, right? So clear guideline on this. That would where the regulation should step in and help the community of innovation. Okay, all right.
Yeah, and this is a really incredible project. So really congratulations to the whole team that built this.
Okay, Chula team, สุดยอดนะ Visit all around the world and impress on Deep GI from Chulalongkorn. Yay. Okay, next question. Okay, gentleman next to you.
Hi. Thank you very much for the wonderful talk. My name is Krikamal, and I am a machine learning researcher. So I spend most of my time researching machine learning. So I have a question about your demo, the prompt-based AI. So I like this demo because it shows how we can actually democratize AI, right? But also at the same time, also it's rely on the assumption that you need to have a good pre-trained model to do this. And therefore, it's put a lot of power on a few companies that can actually have the capability to create this good pre-trained models. Do you think this will change in the future? Will people have more capability in creating this pre-trained model so that we don't put a lot of power into a few? Thank you.
So there was an estimate by Kathy Wood of ARK Investment Capital. She tends to be optimistic, so I don't know if this is totally true, but I'll just quote her results. But her estimate is that the cost of training a large language model is falling by 75% per year. And what this means is if there's a model that costs someone $10 million to train, a year later it'll cost someone $2.5 million, and then a year later, a quarter of that, so maybe $700,000, $800,000 or so. And so I think this is actually pretty encouraging. And we actually see that, was it November 2022? ChatGPT, GPT 3.5 was the leading model, but now there's so many teams that have trained ChatGPT 3.5 quality models. And now, in fact, multiple teams are training sort of GPT-4 class models. And the leading models, and it turns out what's happened is the cost has fallen by maybe 75%, but people are investing more than 4 times more in it after 1 year in these models, which is why the biggest models are still very expensive. But if these trends continue, then I think that it'll actually be more accessible to a lot of people quite quickly. And open source is another very powerful force for this. For example, the Allen Institute for AI has been one of the leading teams training truly open models, meaning that they don't just publish the weights of the model, but the training recipe and the code for training. So I think as these things become available, what we could do with a academic budget will probably always be smaller than what the largest corporate budgets are. But I think things are actually getting more accessible. And this too is why I think defending open source is so important, because the one way it doesn't become more accessible is if someone managed to pass laws to shut down open source.
Thank you.
Thank you, Pam. So we can take 1 to 2 more questions for this session so that we have some time for individual interaction. And also, I need to, Professor Andrew haven't eaten dinner yet, right? So we have to take him, so that not to scare him off from Thailand, we have to treat him very nice Thai food afterward as well. So after have the cut off at almost 8 p.m. So I would take 1 to 2 more questions, and then we'll open up for some networking. Okay, any questions? May take from the gentleman in the white next to the cameras, please, in the back ข้างหลังครับจะยกมือใช่ไหมครับต้นใช่ครับช่วยแนะนำตัวเองหน่อยนะครับ
Okay, so my name is Thanawin. I'm a Chula alumni from the Faculty of Engineering, and I have a great. So we are in the Thailand as a small country, and I would like to know what the challenges and opportunities that you could think of, or any the government policies that we could do to make the AI practical in our country, compared to the United States or the China, because they already have like a lot of fun, a lot of technologies in advance that they could do. So, in your thoughts, what would you think about that? Yeah, thank you.
No, thank you for the question. I feel like, but I know Thailand is smaller than the United States, but Thailand doesn't actually feel like that small a country to me. But I feel like Thailand is a big enough country to do multiple things at the same time. But I think a lot of the opportunities for Thailand will be focused at the application layer. Doesn't mean you shouldn't train foundation models. Worth doing that, maybe train some Thai language models. But I think the vast majority of opportunities might be to build on top of either open source or closed source to pursue lots of exciting applications that are more unique to Thailand, to build where Thailand is already strong. And then in terms of government policy, I think governments continuing to invest in research, continuing to invest in training for all citizens. I think these are important investments. And then we often think of governments as passing laws to make things illegal, but I think governments passing laws to make things legal, to give a clear guide path, like we talked about with Deep GI, is also very important for many different application sectors. And then one last thing I've learned, watching AI take off in Silicon Valley and watching AI take off in parts of China, there's one other lesson I've learned, which is that these things are a little bit complicated, the technology is a little bit complicated, and these things are hard enough that none of us will succeed alone. And I think, well, when I was building Coursera in the early days in Silicon Valley, so many people helped me for no reason at all. And then I was never able to pay them back, right? And I could only maybe try to pay it forward if I could. And I think that when you build community, when many people in Thailand want to help each other out for no reason and no expectation that you ever get a favor done back for you in return. And when there's a community of people to share successes with, share failures with, learn lessons from, share that knowledge of, boy, this didn't work, what happened, and help each other, that community is far stronger than any individual. And so I think for this next period of time, with Chula likely playing a very important, very important central role, I think should be the building of the AI community here in Thailand, because that community because I think this is one of those situations where it's not possible for one person to succeed by themselves, and it's much more likely that with a community that all of us will succeed together. So I hope that we can keep on investing in training, in research, and then also in community.
I I think that's a good ending notes for our guest speaker today, right? So please give a round of applause for Dr. Andrew. So next, I would like to invite President Professor Dr. Willard Puriwat for coming and present a token of appreciation from Chulalongkorn University. Right? Thank you for Dr. Andrew. Thank you very much for the present distinguished speaker talk for help organize and able to pull everyone here. Right? It's such a short notice, but we're able to pull it, and it's a very lively and energetic event.ขอ invite ผู้บริหารทางมหาลัยอาจารย์ครับเชิญเรียนเชิญถ่ายรูปร่วมกันครับอาจารย์ Not the Thai way. Thank you ครับครับผมนะถ้าเกิดใครจะมาพูดคุยกับProfessor Andrew อาจจะตั้งแถวอะไรสักนิดนะครับถ้าเกิดจะมีแถว